Welcome. The purpose of this video is to study tangent lines and specifically the slope of tangent lines because that concept is useful in many different areas of economics, but especially when we study production functions. First, let's start with a very simple example that you often learn in high school. We're going to look at just a linear function where the slope of the line is the same everywhere. When x equals 2, when x equals 1, when x equals -1, the slope is always the same. And in school, you're taught that the slope equals the rise over the run. And in this case, we see here that x goes from 2 to 3 if we're looking at moving from this point to this point. X increases by 1, so the denominator here is 1, and then y increases by 1 also, so 1 is in the numerator, and the slope then 1 divided by 1 is 1, which tells us a very useful result that when x increases by 1, y increases by 1. And so the slope tells us how x impacts y, and that's what we're often concerned with, how one variable impacts another. Now let's look at a nonlinear line. This green line right here is nonlinear in that the slope of the line changes for different values of x. But we're still concerned with how x impacts y, so instead of looking at the slope, there's no such thing as the slope anywhere. We look at the slope at certain points. And we may say we want to know the slope when x equals 2. And in that case, if we want to look at how x impacts y when x already equals 2, what we do is we draw a tangent line like the one shown here. A tangent line is a linear line that touches a function at one point and only one point, at least in a small neighborhood. So you see right here that the tangent line touches this function only when x equals 2. And what we're usually concerned with is the slope of the tangent line because it tells us something important. That slope, and here you can see the slope of this linear line, it's a positive number. And since it's positive, we know that an increase in x has a positive increase on y. And what that slope tells us is how y changes when there are very, very small changes in x. And in here we're looking at a point where x equals 2, and so the slope of this tangent line, if that slope happens to be, let's just say it's 1.5, if 1.5 is the slope, well then that tells us that x has a positive impact on y. It doesn't mean that an increase of x of 1 causes y to increase by 1.5. All we look at that and say is that, well, it's a number. And the bigger that slope, the bigger the slope of the tangent line, the bigger, the larger y increases when x changes by a very small amount. Now, to see how this is particularly important, let's look at the slope at another point on this function. Let's say when x is right here, this would be where 2, 3, 4, 5, 6, where x equals 6. There, if we draw a tangent line, well, it looks like there is no slope. It looks like the slope equals 0. And that is the case. When x equals 6, a small change in x has almost no change in y. So when x equals 6, increasing x by a little doesn't really change y at all. Or another example, suppose we go right here and we study how x impacts y at this point. Now when we draw a tangent line, the slope is less than 0. And what that means is that when x increases, y decreases. And you can tell just by looking at this function when you go from here to here, y decreases. So to conclude, we're very interested in the slope of tangent lines to a function because that slope tells us how y changes when x changes by a very, very small amount.